Good afternoon, pilot teachers, and good afternoon, students.
Good afternoon.
Thank you. Sit down. Okay, we'll continue on with our work on climate, but for the first 5 minutes of our lesson, we're going to do some revision, and then later on, we'll look at the objective for the lesson and the activities that I would like us to complete for our lesson. We're on the work on climate. There were a couple of questions, at least one question that was asked in our last lesson, and we were supposed to come back with the answer to that. That we will look at later on. But we'll start off from what we have covered so far with a revision activity. And the revision activity will require you to quickly copy the sentences that are given and then to fill in the appropriate word from what we have covered on the chapter or the topic on climate. So you will need your exercise books, your pen, pencil, etc. And I'll give you at least 3 minutes for 2 questions. You need to copy down the questions, and at the same time, for the blank spaces, you're going to put in the correct word that will complete the sentence or the statement correctly. So we're starting off now with the revision. There are 2 questions. The first one, the Earth takes 1 blank to orbit the sun. Put in the appropriate word in that space. And number 2, because of the Earth's rotation from west to east, the sun appears to blank in the east. You have 3 minutes to copy down and also to put in the appropriate word. Okay, let's move on to the next 2 questions. I hope you have already filled in the appropriate word or words that should go into those spaces for question 1 and 2. You have question 3, 4, and 5. Again, we have 3 minutes. Question 3 reads, the motion of the Earth that refers to its spinning on its axis. So you've got to write down what is the word that we use to describe that motion. Number 4, the Earth travels in orbit around the blank, the appropriate word that should go in that space. And number 5, night occurs on the half of the Earth which lies in its own blank. You have 3 minutes for those 3 questions. Okay, that's the 3 minutes up. We'll move on to questions 6 and 7. Question 6. When looked at from above the North Pole, the direction of the Earth's rotation is the appropriate word that should go there. And question 7, the sun appears to blank across the sky. It is the Earth that is turning while the sun remains still. So the 2 words that should go in those 2 spaces for question 6 and 7. I'll give you 2 minutes to make note of those 2 questions, as well as that the answers for those 2 questions. Okay, we move on to question 8. I'll give you 1 minute for that. Question 8 reads, as the Earth rotates, the path of the planet that tends away from the sun experiences. Okay, and the 2 last revision activities, that's question 9 and 10. Question 9, the Earth has blank, very important motion. And number 10, because of the Earth's rotation, the sun always appears to set in the... So those 2 spaces for you to fill in, and I'll give you 2 minutes for the completion of question 9 and 10. Okay, we'll correct now. Basically, those are recall questions. They're recall questions from what we have covered on the introduction part on the movement of the Earth. And you are expected to perhaps remember some of those important facts that we have covered by doing this particular activity. So there are 10 questions there. Let's check and make corrections now to those 10 activities. We start off with question 1. We'll start from the back. Frank, to read out the question and give us the answer as well, and the rest of us will make corrections. Okay, Frank, question 1.
The Earth takes 1 revolution to orbit the sun.
Okay, we check his answer. The Earth takes 1 revolution to orbit the sun. The word revolution sounds good in that context? No? what would be another term or the correct term that we should fill in for question 1? Frank will try again, okay? So he's changing his mind on the answer on revolution.
1 year to orbit the sun.
Okay, good. This time it sounds correct. The Earth takes 1 year to orbit the sun. So the word year in that context would be the most appropriate word to fill in. Correct. Number 2, Susan, read out the question, give us the answer.
Because the earth rotates from west to east, the sun appears to rise in the east.
Okay, the word rise in the east, we happy with that? Yes, definitely, and that's also correct. Well done. Ovio, question 3, and the answer to question 3.
The motion of the earth that refers to its spinning on its axis, rotation.
Okay, rotation is the word that we want for the answer to that question. Good. The next one, question number 4.
The Earth travels in orbit around the Sun.
Okay, the word that should go there is sun, correct? Question 5.
Night occurs on the half of the Earth which lies in its own axis.
In its own axis. He's given the word axis. We double check. Does it make sense in that context? Night occurs on the half of the Earth which lies in its own axis. Anyone disagree with that answer? Yes, a couple of students disagree with that answer. Silo, what is your answer to question number 5? In other words, I'm saying axis is not the word we want in that statement, so axis is not correct. Silo, number 5.
Night occurs on the half of the Earth which lies in its own shadow.
Shadow, correct, is the word we want in there. That's the best word to actually fill in the context of question 5. So the word shadow, answer for question 5. Question 6.
When looked at from above the North Pole, the direction of the Earth's rotation is anti-clockwise.
Anti-clockwise is correct, and that's also the answer that I want in that particular question. Question 7.
The sun appears to move across the sky. It is the earth that is turning while the sun remains still.
Okay, good. The word moves is what we want in that particular blank space for question 7. Anita, question 8.
As the Earth rotates, the part of the planet that turns away from the sun experiences darkness.
Okay, darkness is correct. Could there be any other word that we can put in there beside darkness? Yes. What would be another alternative? If you have darkness, that is correct. We're looking for other possible alternatives.
Night.
Night. If you did put down the word night, you can also get that correct. Okay, we move on. The next one, Gibbs, question 9.
The earth has 2 very important motions.
Okay, it's 2, the word that should go in question 9 there. The earth has 2 very important motion. And finally, Caleb, question 10.
Because of the Earth's rotation, the sun always appears to set in the west.
In the west. Okay, we know the sun rises in the east and it sets in the west. So the correct word that should go in question 10 there is west. Okay, those are again recall questions, some of the words that we have used when we were looking at the information on climate from our introduction. We'll move on. Our objective for our lesson today is basically to look at the second movement that the Earth does beside rotation, and that is the movement of revolving. The Earth, beside rotating on its axis every 24 hours, it also revolves around the sun 365.25 days. So our objective is basically to look at the effect of the Earth's movement in terms of its revolution around the sun. But before we do that, let's go back and recap now on what we have covered on the movement of rotation. What we have covered on that first movement of rotation, the Earth rotates on its axis every 24 hours from west to east. And to demonstrate that on the globe, it's simply the movement of rotating on its axis from west to east every 24 hours. As a result of that movement, that's the movement of rotation, we looked at two important effects. The first one, the movement of rotation results in day and night. The areas of the Earth where they are directly in line with the sun experiences daytime, or sun shines directly above or on them. Meanwhile, those areas which are away from the direct heat or the direct rays of the sun are actually in the night, or they experience darkness. Secondly, the other important effect of the movement rotation is the difference in heating of the Earth's surface. You were asked to actually complete or to do a homework, and that homework was based on construction of a diagram, of which that diagram should show those two effects of rotation. You double check also on that particular diagram so that you can make correction from looking at the information on the monitor. Your diagram, if you did look at the booklet Introduction to Climate, or the booklet Climate, that's the booklet we are using, you will find that information on figure 4. And from figure 4, you could use that to construct your diagram to help you with the explanation on the information on day and night, and also the difference in the heating of the Earth's surface. So looking at the diagram, all those areas that are in white color are directly exposed to the sunlight, therefore they experience day. Meanwhile, on the other side, all those areas that are in the darker gray color experience night because they are away from the sun, they experience the nighttime. Similarly, with the same diagram, you could also explain the difference in the heating of the Earth. We note that as the sun rises, it does not only bring light, it also brings heat. So therefore, early in the morning, you would note that the sun's rays striking that part of the Earth, the temperatures start to rise. By the time it is midday, then the sun is directly overhead. Therefore, that is also the time when the temperatures are at the maximum. Then it goes towards the afternoon. The sun starts to set now, and this time the temperatures also decreases. And that's generally what you should have for the explanation of the Earth's rotation resulting in day and night, and at the same time, the difference in the heating of the Earth as a result of that movement. Okay, and that's your homework. You're supposed to have completed that, but you can also check and make your corrections in line with what I have explained. We have also noted the movement of the Earth when it is rotating. When you are standing above the North Pole and you're looking down on the Earth from the North Pole, you will also notice the rotation of the Earth. And we've already done an activity of which it also tells us that the movement is always in an anti-clockwise direction. While the Earth is actually rotating on its axis from west to east every 24 hours, from above the North Pole, when you look down, you will see that motion is in an anti-clockwise direction. Okay, we move on. Also, in our last lesson, we had information about some of the important facts when we were comparing the planet Earth with the other planets. We were mainly interested in the rotation and how long it takes for each of those different planets to actually rotate on their axis. We found out the Earth, we know, 24 hours, which is 1 day. And we also looked at the time taken to orbit the sun, and as well as that, we looked at some other important or necessary information to go with the work on rotation. While we were looking at this set of information, there were a couple of questions which were actually based generally on the information on the 9 planets. So we go now to the question that was asked by Ovio, and I also hope you have done your homework in trying to find the answer to that question. His question again was, he looked at the diameter of the Earth, which is 12,756 kilometers, and he compared it with the diameter of Jupiter, which is 142,800 kilometers. And he asked the question, why is it that the Earth's diameter is small, but it takes a longer time which is 24 hours for the Earth to rotate, in comparison to Jupiter, where it has a larger diameter, but it spins or it rotates a lot faster, 10 hours. Anyone found an answer to that question? Did you do that homework? Okay, if you didn't, then perhaps I'll give you the answer and you can double check with. You have a handout which was distributed, and that handout contains some information about the 9 planets generally. Okay, Gibest has got the answer, so he's going to help us, and then I'll also give you the answer to what I have actually found for that question. Okay, Gibest, can you also explain to the class now what you have found in terms of that question we had last week, or in our last lesson?
I have found that the planets near the sun have heavy materials than the planets far away, so Earth is much heavier than Jupiter, so it tends slower than Jupiter.
Very good. And that's the answer I was going to also give you. The planets which are closer to the sun tend to have heavier materials in terms of their makeup, whereas the planets which are further away from the sun, the materials are more lighter. Therefore, in terms of rotation, the heavier materials tends a little bit more slower when we are comparing Earth and Jupiter compared to Jupiter with the lighter materials. We look at the planet Jupiter, it's a big planet, but most of what surrounds the planet Jupiter is mainly gas, which is lighter compared to the solid parts of the Earth, where we are not only the solid parts, but the Earth itself having more solid material, which makes it a little bit more heavier. So what Gibest has actually given is the correct answer to the question of your ask last week. Having that particular question, and I think a lot of you might also have other questions with regards to generally the 9 planets in our solar system, I'm going to give you a research work, of which from that research work we are going to get a couple of you to come back to the class, and you are going to actually do some presentation. And from your presentation you are going to explain to the class some of the interesting facts about the different planets that we might not be very much aware of. And in that way, perhaps it will also help us look at the other characteristics that we do not have time to actually go through doing in class together. But I'll give you that work towards the end of the lesson, and then I'll put you into groups, 9 groups, and then from the 9 groups you will be told to go off and do some research, and then you will come back and you will present characteristics and other interesting maybe points about each of those planets to the class. And perhaps that will be done for our lesson, our next lesson. I'll explain that to you towards the end of the lesson. We'll move on. Today what I'd like us to look at is basically the movement of revolving around the sun. And we already note that the second movement that the Earth does is the revolution of the Earth around the sun, and it takes 365.25 days for the Earth to complete one full revolution. I used Val in our last lesson, and I used it as the sun, and I also showed you the motion that the Earth takes when it is actually revolving around the sun. The rotation movement is simply this: on its axis every 24 hours from west to east. The revolving motion is actually following the orbital path of the Earth around the sun. Note that while the Earth is actually revolving around the sun, the axis is always static or steady or constant. It does not move just because it's here and then it goes there, it moves that way, comes this way, no. The way in which the axis is actually placed, that is exactly the way in which the Earth is positioned while it is actually revolving around the sun. Okay, with that now, with that demonstration, we also noted that while the Earth is actually doing the motion of revolving, there are 2 very important effects of that movement. And the 2 important effects are, 1, because of the revolving of the Earth around the sun, as well as the tilt of the Earth contributes then to the seasons. In Papua New Guinea, we do not experience the 4 seasons that the temperate countries experience. And I'm going to go through the explanation of that shortly. The second effect of the revolution of the earth around the sun, it contributes then to what we call the varying length of day and night. Okay, perhaps to explain a little bit more on those two effects, the season and the varying length of day and night, I have a chart here of which we are going to fill in, and at the same time, perhaps if you have any questions after we go through the information on the chart, you may feel free to ask. Note the title of the chart. It says there, the apparent movement of the sun. We already know that the sun does not move. It is the planets that actually orbit around the sun. So do not see the title as the apparent movement and you're thinking the sun moves. No, the sun stays in that same position. It is the other planets that actually rotate and also evolve or revolve around that sun. If we look at the explanation of the seasons and the varying length of day and night, this is one way of actually showing that information, and perhaps we might understand it a little better. This is not the only way of showing this information. In our next lesson, I will look at the second way in which we can show the same information. Note, I have the red line here, which is labeled 23.5 degrees to the north. What is the name given to that line, which is 23.5 degrees to the north? Celeste, can you tell me what is the name of this line?
The Tropic of Cancer.
Okay, this is the Tropic of Cancer, good. So here, this diagram or the lines here are not to scale, but just to show you the apparent movement of the sun so that we can look at the seasons and the varying length of day and night. 23.5 degrees to the north, the Tropic of Cancer. This line here is labeled the equator, which sits at 0, and then 23.5 degrees to the south, the name of this line. 23.5 degrees to the south. Kiran?
The Tropic of Capricorn.
Tropic of Capricorn, good. It's important for us to note these particular areas because the sun, when it is actually directly overhead, in the northern hemisphere, the sun will always be directly overhead only at 23.5 degrees. In the southern hemisphere, the furthest south that the sun can be directly overhead is 23.5 degrees south. This particular globe that I have here, if you look at it carefully, of which I'm going to pass that around, you will see a line. And this line here, not the equator, there is a line which is actually drawn around the globe. And this line here shows the position of the sun at different parts of the world at different times of the year. So if we look at the furthest point to the north is about here. And if we note that is 23.5 degrees to the north, that is when the sun is directly overhead. In its apparent movement, the sun continues on to the furthest point in the south, which is 23.5 degrees, the Tropic of Capricorn. And then the orbital path or the apparent path that it actually takes when it is, or when the earth is revolving around the sun. You pass that around and you can have a look at that. Meanwhile, also note the explanation that I will go through for this particular chart. So here I'm saying that the furthest point to the north that the sun can be will be 23.5 degrees to the north, Tropic of Cancer. When it is June the 21st, this is the time when the sun is directly overhead the furthest point in the northern hemisphere. June the 21st. When the sun is directly overhead the furthest point in the northern hemisphere. What happens then is, when the sun is in the northern hemisphere, anyway between here and it is actually moving towards the furthest point in the north, all those areas which are in the northern hemisphere, they experience the season summer. Meanwhile, the opposite, all those areas in the southern hemisphere will experience winter. June the 21st, the furthest point in the north. What happens then to the hours of daylight and the hours of night? When the sun is directly 23.5 in the furthest point to the north, this is when the northern hemisphere experiences their longest days and their shortest nights. And the hours of daylight can go up as far as 18 hours of daylight, 16 to 18 hours. So for 16 to 18 hours, these areas in the northern hemisphere, especially the areas furthest north of 23.5, they'll experience 16 to 8 hours. So 16 to 18 hours. So say, for example, a place experiences 16 hours of daytime. How many hours of night would they experience? How many hours of night? The Earth rotates on its axis every 24 hours. So if the areas in the northern hemisphere when the sun is furthest north experiences 16 hours of daylight, how many hours of night will they experience? 8 hours. So for nighttime, it's only 8 hours for them. Daytime, 16 hours. So here we are saying longer days, shorter nights. The sun does not just shine directly here. It will take 3 months for the sun to actually now be directly overhead the equator. It is now September the 22nd. The sun from June the 21st, June, July, August, September. By the time it is September the 22nd, the sun is actually directly overhead the equator. And when the sun is directly overhead the equator, there is equal hours of day and night in both the north and the southern hemisphere. So if it is equal amount of day and night, how many hours of day? 12 hours. How many hours of night? 12 hours, giving us 24 hours. That's when it is September, after 3 months that the sun has actually moved to this position. It will take another 3 months for the continued movement until it is December the 22nd that the sun is directly overhead the furthest point in the southern hemisphere, and that is the Tropic of Capricorn. So when the sun is directly overhead here, those areas in the southern hemisphere experience longer days and shorter nights. Meanwhile, the opposite is for the areas in the northern hemisphere. Okay, think about it. If it is December the 22nd, it is summer in the southern hemisphere. What season do you think it is in the northern hemisphere? It is winter. So you know the winter season for the northern hemisphere climate usually occurs in the December, January months. Because the sun is directly overhead here, 23.5 to the south. It is summer in the southern hemisphere, it is winter. At the same time, it is winter in the northern hemisphere. The sun does not just stay here, it will take 3 months for the sun to be directly overhead the equator again. It is March the 21st. When the sun is directly overhead the equator, we have equal hours of day and equal hours of night. And then 3 months and we are back to June and the cycle continues. This explains the reason for why we have varying length of day and night as one of the effects to do with the motion of the earth revolving around the sun. That's not all. The other effect we said is to do with the seasons. So let's look at the seasons. When we are actually noting the seasons, it is also important for us to note the tilt of the earth. Along the horizontal plane, the earth is actually tilted at an angle of 66.5 degrees. Along the vertical plane, we can say the earth is actually tilted at 23.5 degrees. The tilt of the earth plus the motion of revolution also has a big influence on the seasons that are experienced. When the sun is actually directly overhead here, you've already told me the season in the northern hemisphere is summer. The sun moves here, 22nd September. What season is it now in the northern hemisphere? If the sun is here, what season? Catherine, what do you think? We're following the northern hemisphere. In the northern hemisphere, June the 21st, summer. It is September the 22nd. What season is actually in the northern hemisphere when the sun is over the equator?
Spring.
Summer, and the next one she says spring in the northern hemisphere. We agree with her? I don't. Shelley, what do you think? What season comes after summer?
Autumn.
Autumn, yes. So summer, straight after summer, the sun is directly overhead the equator in the northern hemisphere. The season now will be autumn. That's the fall. All the leaves start to fall. You're following? We're moving down another 3 months. By the time we reach December the 22nd, what season is it in the northern hemisphere? Winter, because straight after autumn comes the season winter. Okay, it will take another 3 months when the sun is directly overhead the equator. What season is it now in the northern hemisphere? Spring. Straight after winter comes spring. And then the sun is directly overhead again, and the season is summer. So you see the seasons also rotate following where the sun is directly overhead at the different times of the year. You will be required now to make note of this diagram, and we're going to go ahead with more explanation and filling in this chart with the different seasons and etc. in our next lesson. You'll be required to make note of this chart, perhaps for your homework, but to finish off our lesson, here are some activities to see whether you have understood the explanation of what I have just looked at on the revolving earth. Okay, you have a passage, you have a couple of missing words, and from the passage you are required to fill in the correct words from the passage into those spaces that are left blank. Okay, class, with that information, that will also bring us to the end of our lesson. I will want us to correct those activities in our lesson tomorrow, so ensure that you also have the correct words to go into those blank spaces. If you can stand up now, class. To the pilot teachers, our keyword for lesson 86 is revolve. Good afternoon, and thank you, students.